Alright, so today we're going to do a little bit of review of completing the square. And before we go to that, I want to start by saying that we have to remember that when we square a binomial, we end up where the binomial is a coefficient of 1 on the variable and an end number. We always end up with a pattern here. So x plus 1 squared is x squared plus 2x plus 1. X squared plus 2 is x squared plus 4x plus 4. X plus 3, x squared plus 6x plus 9. If you change the sign, the middle number simply changes. And what it becomes is there's a format here. If you have x plus a squared, you end up with x squared plus 2a plus a squared. And if you change the sign, all that changes is the sign of the middle term. This is the powerful part, realizing that these are equivalent to one another. Because you couple that along with the idea that this problem is easy to solve. That you can quickly take square roots of both sides. And you get x minus 1 equals plus or minus the square root of 3, opposite side, opposite sign. And you quickly go from the blue problem to the answer. So we like this format of x minus some value of a quantity squared equals b. We can quickly solve it like we did an example on the previous page. So when we're given a problem like this, we can't just take a square root. There are two terms here. When we look at the top, we know we have to get the one term squared equals b. So the first thing I always do is I put it in descending power, bring the 13 over, and ask myself, is this factorable? This does not factor. So I'll send the 13 back to the other side. Well, we want it to look like this. We want to fill in the blanks. We want to get it to this format on the top. So if I go, I see I have x squared plus 6x. So if I go back a couple screens, x squared plus 6x, if I had plus 9, it would be equivalent to x plus 3 squared. Well, I'm allowed to do anything I want. So I will add 9 to both sides. And by doing that, I have now created this, I've completed the square. So that I have the product, 3 times 3, and I have the sum, 3 plus 3. So I can change this to x plus 3 quantity squared. And then you get the other side, and 13 plus 9 is 22. Again, take the square root of both sides. Opposite side, and I have a solution. It is a quick method here, and it helps us go from here to here. All right? We have to notice that this number here is half of this. So when we get ones that aren't integers, such as and again, first thing I do is I look at x squared plus 7x minus 3, and I ask the question, is it factorable? No, it's not. So I send the 3 to the other side. And this is where it's going to get a little more difficult, because I know that I have to get 7. Well, I have to take half of that term then. Just like on the previous page where it was 6 and the square was 3, we have to do 7 halves. Well, I can't jump from here to here without having a trinomial. 7 halves plus 7 halves is 7. Well, we have to get the product of 7 halves squared. Whatever I do to one side, I must do to the other. And if I do this, this becomes the binomial squared. The other side becomes 3 plus 49/4. And again, before I can take the square root, I have to get one term on the right side also. This becomes 3 is 12/4. 12 plus 49 is 61/4. Again, we're to the point now, take the square root of both sides, and I get x plus 7 halves equals plus or minus the square root of 61/4, which we can reduce to x equals -7/2 plus or minus the square root of 61 over 2. These bottom denominators should be multiples of each other. This works great, especially if the coefficient here is 1. So what do we do now for a problem like this? Again, the first thing I do is I get everything on one side. And I say to myself, does this factor? Well, this is a case where we'd have to have either 4x and x and 5 and 1, and to save time on the video, I'm not going to factor. I'm going to complete the square. I'll move 5 to the other side. And at the same time as I move 5 to the other side, I'm going to get a 1 here. So I can have some x plus a squared. Because if you do that, the coefficient's only going to be x squared. The lead term will only be x squared. Coefficient of 1. So we will divide by 4 and move 5/4 to the other side. We end up with x squared plus 1/2 x equals -5/4. I can't stress enough that completed square works the same whether this is 6 or 7 or 1/2. It's always half of the sum. So half of a half. Well, half times half is a fourth. So I know the square I need is 1/4. But I have to add back the 1/4 squared on both sides. Because I have to work an equivalency. I have to have a trinomial, that's a square, so I can get here. We create a perfect square to go to a binomial square. These are equivalent sides. On the other side, when I square this, I get 1/16. I have to multiply by 4, so I'm going to get -19 over 16. Now, if you're in Algebra 2, just learning this, you might not realize how to deal with this sign. I take the square root of both sides. So for now, I'll go plus or minus -19 over 16. Move the 1/4 to the other side. And I get plus or minus the square root of -19 all over 4. We realize that this can be written as 19 times the square root of -1, which is I. So my final answer is -1/4 plus or minus the square root of 19 over 4, I. And we have found the solution for x. I'm going to do another example here really quickly. And I'm just going to use the complete the square method. I am not going to worry whether it factors or not. I will put it in descending power. And I will first get rid of the coefficient and rewrite it. Again, I know that when I have x squared plus 1/3 x, I can always make a square by taking half of the middle term. Half of a third is a sixth. A sixth squared, instead of writing it squared, I know I can write that as 1/36, and I have to do both sides. One of the big errors is people forget to put it on both sides. This trinomial becomes this binomial. On the other side, when I do the math, I get 59/36. Take the square root of both sides. And again, we know that the negative number creates an I. I get -1/6 plus or minus the square root of 59 I over 6. Lastly, the big thing we can do is derive the quadratic formula. If we start from a general form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers, we can derive the formula. First step, again, is we cannot handle a coefficient on x squared. So I'll divide by a to get rid of the coefficient on all terms, including the 0 on the other side. But 0 divided by a is 0. And I'll move c over a to the other side. And I'll get x squared plus b over a x equals -c over a. And again, we come back to whether this was 6, which half of 6 is 3, 7, half of 7 is 7/2, there's 3.5. Half of a half was a fourth. Well, I got to take half of b over a. So half of b over a. Well, it's simply a multiplication problem. And I get b over 2a. And if I'm going to make this jump, I have to have a trinomial. So I have to have b over 2a squared. Well, I'll do the math. And I get b squared over 4a squared when I square that. But the problem is I have one term on the left. I need one term on the right. So we have to do a common denominator, which I will make 4a squared on both sides. I'll write this as x plus b over 2a squared still. I will combine the tops, and I will get b negative 4ac plus b squared all over 4a squared. But just for simplicity of writing, we're going to switch the numerator from negative 4ac plus b squared. We're going to put the b squared first. We can write it as a subtraction problem. B squared minus 4ac. Now we have one term on the left, one term on the right. Take the square root. And again, you square root. Remember, when I take a square root of the entire thing, I can take the square root then of the top numerator and the bottom denominator separately. And I can move b over 2a to the other side and get negative b over 2a plus or minus the top, which we call the discriminant, and the bottom becomes 2a. Common denominator. That way you know it, did it correctly. And so you can finally write it this way. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And remember, we started from the general format. Now we've derived the quadratic formula. So you could just pull the coefficients and plug them in the equation. There's 4 problems and the quadratic formula for your review. Try to work them and watch the video multiple times. Thanks.